we could work on a whole bunch of different stuff.
Yeah, pick whatever.
Yeah. Let's actually work on some of the relationship stuff for schema record. That might be fun.
Should be.
So let's call this, we'll check out any branch here. Um, Legacy relationships. All right. What we need to do in here is let's start with the read case, and then we'll get to the set case.
Sure.
So schema record is just a proxy. So the class in the constructor for the class. In a constructor, you're able to do a special thing where you can actually return the type of this. Like most of the time you don't think of doing that. Like most of the time the constructor just like sets up some state. But you can also return on this. And so that's what we're doing here is we return a proxy around ourselves.
Oh, wow.
So that's like,
Why it's useful?
so what is useful is we don't actually define any properties on schema record. What we do is it's just a class that allows us to very quickly set up a new proxy in a certain shape. And in this proxy, what this gives us the ability to then do is say, hey, if you access this particular, you know, property on me, what do you want to do when I access this, right? And or if I'm setting this property, what do you want to do? So it's a trap. It's an
Yeah,
interceptor.
you catch all the accesses.
Exactly. So I capture everything, right? And so what we do is we capture that access, and so that gives us the prop. And we look and we see, is that prop one of our special symbols, which we only have a few of? And if so, then we delegate to our special symbols. We have to handle a couple of like built-in things that are just like normal for all kind of objects in the JavaScript. This is a property that we're going to migrate to a symbol and just have failed to because we don't want to do anything that's not a symbol or in the schema. So like this is just a to-do here with like make this a symbol. And so then what we will do is we grab the field, and to get the field, what we've done is we check against the identity field. So like when we instantiate the schema record, we ignore the embedded code for now. Like I'll explain embedded later. Anytime you see the embedded branch, just pretend it doesn't exist, and we'll get to what embeds are later. But what we do is when we get a schema record, we go get the fields from the schema service associated to that identity, and we additionally get the identity field. So the identity field, we go ask based on our identity, we say schema for this resource, go get the identity property off of it. So we have the identity field, and then we have a map of fields. So down here in the get, we say the field that we just tried to access, is that the identity field? If so, use the identity field. Otherwise, from the fields map, get this particular thing. And then if we don't have a field, we're going to error. But there's a couple of cases where you don't have a field and you still don't want to error. So these just quickly capture those where it's like ignored globals. That ignored globals is like there are weird special properties that certain JavaScript primitives will check for that we have to like act like they exist even though they don't.
Okay, because of the proxy setup.
Yeah. So like it might be checking for like symbol.iterator or like symbol.proxy or something like that. So like we have a list of those things that we have to ignore so that it doesn't error when it shouldn't. If it's the constructor, we just return ourselves. And if it's a symbol, actually a symbol, we just return undefined. And then finally, what this means is once we've excluded those cases, if we didn't have a field and you're not one of those cases, then it means that, hey, you're probably missing something in your schema.
Right.
So we throw an error. And so then we take the field kind and we just switch over it. And this is the entirety of schema records. What makes it so like simple is that everything a schema record does is literally just pulled from a field schema. So if we're an ID case, so we're the identity case. Entangle a signal. So this is that abstraction that we've built around signals. So this is the thing that makes this property reactive. And then we return the value. Same thing for hash. In hash, we give you the ability to basically create an identity that maybe isn't a truly perfect identity, but a good enough identity by like computing an identity from the value of all of your attributes. So that's very useful for like just embedded objects or like deeply nested objects where you don't have like an ID property or a primary key property, but maybe there's some other thing that you can use to know the identity. Locals, if you read the schema RFC, you call these out. Like these are a special case. We don't really expect people to use them, but we've implemented a few things as them. The idea of a local is it's like a primitive value field that is attached to the record instance, but does not go into the cache at all. So it's only on this proxy instance and will never go into the cache. You can't access it from the cache. It's completely like it could go away at any time. This is useful, for instance, for like is destroyed and is destroying. Those semantics for like a record instance, because that's not doesn't apply to your data. It applies just to that record instance, right? So that's why it's local to the record.
Sometimes I do, maybe it's not a good practice, but sometimes on a model, I dynamically define is checked when I have list
Exactly,
of and I use is checked as a local.
yeah. So you could do that, but we really want to discourage that.
Okay, so okay.
But that is exactly the kind of case that falls into that. But like we really want to discourage that because if you put it on the record, it's no longer a state that is pulling from your canonical state, right?
Right.
And the danger of that is that you put something like is checked onto your model. Well, maybe it was checked in this one list over here. What happens when the model is in this other list over there?
Yeah, it will still have its check. Right?
You'll still have it checked and wasn't maybe not supposed to. Right? So you've leaked state in that case, so in a bad way. So like we really don't want people to use locals all that much, if at all. But there are a couple very specific cases at the infrastructure level where it does make sense, and so it exists as a concept because we want to be able to describe everything as schema.
Okay.
Then you get, this is your generic field. So this is like the replacement to attribute. Again, we entangle a signal, we compute the value. The reason that we compute the value is that we're going to take this schema and maybe on that schema you define a transformation. So we're going to get the value from the cache, run it through that transformation, and give you that back. Resource is like the replacement for a belongs to. Derived. With derived, what we'll do is it's a field that doesn't exist in your cache data, but is derived from that cache data. So
it's a full name.
It's the full name situation, okay. Exactly. And so you're able to, in your schema, say this is a field, but it's not actually doesn't have its own data. Here's the function you run to generate its value.
Okay.
And so when you
does it end up in cache or not?
It never is in the cache.
Nice.
Right. So whenever the cache state changes, this will automatically recompute. Well, it'll recompute on pull on access,
Yeah.
right? So, but it's like you had defined a cached getter, but like expressed in your schema. Schema array is like the replacement for like a model fragment array, if you will. Um, the difference between schema array is like an array of like simple values that
Array of primitives like boolean strings and stuff like that.
exactly, right? Whereas a schema array is an array of like objects that will have a schema.
To represent.
Yeah. And then so that's the same difference here between schema object and object. Object is a bit more like a dictionary to more primitive values, whereas schema object is like I am an object with a very well-defined shape. So you'll notice, we're missing cases still, and that issue that Jopi had opened was that you'd hit this error. Hey, collection isn't implemented, but we haven't implemented belongs to, we haven't implemented collection, and we haven't implemented has many. So let's start with belongs to, because I think that's going to be one of the easier ones, and then we'll go from there. So we're just going to add a new case. And because we've typed all this, it's telling us, hey, these are the 3 we're missing so far.
Wow, that's good.
Right? So we'll start with belongs to. Now, this is this is going to be like the most of the work here is actually to go back to the model implementation and refactor the model implementation into a form that we can reuse some of its code.
Okay.
So the way that we will do that is similar to how we've redone some of these other things. So if we let's go here to the model. If we look at the model definition, there's this weird thing in the model definition now that needs to be there. It's not actually weird, but like it's going to look weird at first. If you look at our model class, you'll notice that we also have a model interface.
Right.
We're relying on declaration merging here in TypeScript to combine these two things.
Can you explain the declaration?
So we say we have an interface model and it has these methods or properties.
Right.
And then we say we have a class model that has, it's been,
It's
yeah, well, no, so we're implementing a different interface here, but what this is going to do is the final type for model will have everything that's in here and everything that's in here.
okay.
That's why it's declaration merging, right? You can't do this with types. You can only do this with interfaces. And the reason you can do it with an interface in a class is that class is secretly also like an interface and a type.
Right.
So this is why we're able to say interface model and class model and have them squashed together. The reason we do this is that these methods are no longer defined on the class. They're defined down here. Notice we on the prototype, we put them in from these methods. And these methods, we're importing them from model methods. And in here, we have all these model methods that are individual functions. Why did we do this?
Yeah.
Right? Like this seems like really weird factoring. Why wouldn't you just put it on the class? Well, it's because if we want to have a really good migration path between the legacy model and schema record, there's times where we need exactly the same logic and behavior to work in both.
So it allows you to reuse the code from the model and put it in the schema record.
Exactly. So what we did here is we have a schema, the schema provider here. And in this schema provider, this is like the model packages implementation of the schema service. But it also has maybe it's not in here. It's in Oh, it's going to be in migration support. That's right. Here. So migration support is a new import path in the model package that exposes things for using with schema record while you still have a model.
Okay.
And uh, we have in here one big giant array of all the legacy fields. Right? Uh, and then we have this legacy support map, which is just a weak map between a record and some state that we have to set up to support that record when in legacy mode,
Okay.
which I'll go into later. And then we have this function legacy support. Legacy support is actually what we refer to as a derivation in the schema.
Okay.
All right? Because remember, derivations don't have data in the cache. They produce a thing from data in the cache, right? Well, what we've done here is we have this with defaults method that takes in a schema for a resource, and it adds additional fields into it to support the legacy.
Yeah.
And so what we're doing is we're saying, okay, if you're in legacy mode, first off, we mark the schema as being in legacy mode, because we're not going to even allow some of this stuff if you're not. We say your identity has to be this, because in the old school models, ID always had to be your identity. And yes, this means that in schema record, you can have a different property be ID. You don't have to have ID be ID. So then we take that list of legacy fields, and for each one, we push a new field in, and the type, the kind is derived, and the type is this special legacy derivation, which we're going to register down here in this register derivation.
So, can I say that all the models are secretly schema records now?
No, because like if you're using the model as a model,
Yeah.
that's what you get.
Okay.
But all of the features on model have been ported out into this pattern so that secretly they can be expressed as schema. And so literally everything. So this is where those locals I mentioned come in: is reloading, is destroying, is destroyed, and then everything else is one of these legacy fields. And so like literally that's what it is. Like we didn't have to do anything crazy to use the idea of schema to implement all of this. Like, I mean, some of the old model APIs are just total bullshit. Like they shouldn't never have been designed. But like we didn't have to do anything crazy to support them, even though they probably shouldn't have existed, because like the paradigm of expressing things as schema is flexible enough. We could do anything that existed before. We can also do a lot of new stuff now, but we could have done anything that existed before. So that's all we do. And like that legacy, we have this list of legacy fields. The actual function for that, that I closed over before, is just a big switch over which prop am I. And for each one, it goes and does the thing that it needed to do for that state. So it's either returning the function or it's returning the constructor in that case, or for all the Booleans, it's returning the current state property that was associated to it, or whatnot. It feels like over engineering sometimes, but like it's kind of really been neat to figure out how are we going to craft this bridge, and this is how we crafted the bridge. Now, we want to implement belongs to and has many. What's really tricky about belongs to and has many comes down to this legacy support paradigm. In what legacy support here is, it comes down to this paradigm. So if we go back to model for a moment, maybe not even to model. Let's go to like the has many decorator. If we're in the has many decorator, it's secretly still a computed property for reasons. the reason that adder belongs to and has many are secretly still computed properties is you can't create getter setter pairs or for classic Ember object syntax using that are also decorators without it.
Okay.
So like the hacky dirty secret here is that when we return a computed, it's an instance of a class called like an Ember computed, and on a classic class, when you assign the key to a value, when you say name colon adder,
Yeah.
when Ember is creating the class after you've called create, if it sees that the value is an Ember computed, it goes and installs it like it was a decorator. And so you have to use computed to have that happen. And so this is why like we're not, this is technically a decorator. Hasmany here is technically a decorator. People these days are used to thinking of it as a decorator.
Right. Right.
It's not actually a decorator. It's actually something turning something that is both a decorator and an Ember computed. And we do a little magic to figure that out. Which, so
How do we gonna port this?
so that's this is where this gets tricky. So it's this piece of it that's tricky. So it turns out that Hasmany and belongs to all both call into lookup legacy support this, get Hasmany, and or set is kind of the same thing as you don't need a return in the new case, but like we get the existing many array. We look at the legacy part, get the existing many array, and then we splice it with all of the new stuff. For instance, all right, because the set on a has many is a full replace,
Yes.
right? Same thing with the belongs to here is with the belongs to on the get. Just look up the legacy support, and we're going to return get belongs to.
All right. So
Right.
all we need is to build that.
So all we need to do is build that. But what's tricky about this is the entanglement of these two things. So schema record, we don't want to require model to exist,
Right.
right? But the thing is that this is tied to whatever this legacy lookup legacy support is, right? So let's go look at that legacy relationship support. It's a big giant class. This is, if you ever in the old days looked into internal model, most of what was in internal model for relationships is what is now this class. Because internal model had kind of two separate roles, and that got split up over time. Well, three. The first of those roles, the first one that we removed was identity. Internal models used to be the identity of a record, which was just a mistake because it was very difficult to work with internal model as identity. So that's once we landed identifiers in the 3.x series, that responsibility went away. The second thing that internal model used to do was it was the data cache for that record. Well, that was a mistake because both it made it very difficult to work with cache data because it's an instance of a class, not raw data, and also because it meant that you had to have a class instance to work with the data. I guess that's the same thing I just said, but even more, it's like you have to have a class per resource now to store the data. That's a really high memory overhead. It's really high allocation and instantiation cost.
Yes.
Right? The cache design today is what we call a singleton cache. It's a singleton cache because there's literally only one cache instance, and then it's just a map of from identity to raw data. So much better performance, much lower overhead. So here, that third thing that internal model used to do was it was kind of a stateful bookkeeping of the objects that we would hand out to the UI for relationships. So like in a cache, we have the raw data for what's the state of my relationship. But then we hand you out like the many array or a promise many array or a belongs to or promise belongs to,
Yes.
right? Right. So we have to keep track of bookkeeping for promises. We have to keep track of bookkeeping for those promise belongs to, promise has many and many arrays, like, and that's all tightly coupled to the record instance,
Right.
right? So that's why this still exists, is it encapsulates how do I do the bookkeeping for those objects specific to a record, as well as a little bit of nuance. The old school relationships have some kind of bonkers semantics around how do I know if I need to hit network and fetch if I'm an async relationship.
Right.
So like we have to do a whole lot of checks to figure out am I in the state that a request needs to be made? And then even once we figure out that if a request does need to be made, we have to do a whole bunch of more checks to figure out, well, what mode am I in for making that request? Because if you've ever tried to like customize how like a belongs to or a has many is fetched, you might have bumped into, wait, sometimes it seems like I'm calling find many, sometimes find record, and sometimes find has many, and sometimes find belongs to, and sometimes find record. Like what happens here? Why so many different methods getting called on my adapter?
Yes, yes, yes.
Like which one do I actually need, and why can't I get the context of like the relationship? Well, it all depends on what mode the relationship's in, and that depends on, does the relationship have a link or not. So you will only call find has many or find belongs to if the relationship has a link in the cache.
Yeah, mine doesn't have these.
Right. So that means that for belongs to, you're always going to call find record, which just doesn't have the context of what's my parent and which relationship am I.
Yes.
Right. And then for the many array, that means that you're either going to call find many or find record. Now, how do we make the decision as to which of those to call? Well, it depends. Did you turn coalescing on your adapter on?
Yes.
Right? If you turn coalescing on, then we're going to call find many. If you didn't turn coalescing on, we're going to call find record. So like it's a whole complicated dance to figure all that out, and this class deals with that,
Right.
right? So it's a lot of code that would be dangerous to reimagine because people have gotten used to how their particular relationships work.
Yeah.
Right?
Exactly.
This is Hiram's law. We can't change this very easily, right? So if we want to have this same paradigm of has any it belongs to for legacy reasons could be used on a schema record, we need to use exactly this thing.
Okay.
All right. Well, that probably means this can't live in the model package anymore. I'm thinking that what we do is that the legacy relationship support comes out of the model package and goes into the legacy compat package.
Yeah.
That's probably the best tie. And or what we could do is that something like this, we could leave it here, but we could come back to the record. And what we can say is something like this. We go up here to the top, and we're going to give ourselves a new const, and we're going to say const has model package equals dependency satisfies at Ember data model, and we just give it a star. So
If we have a model installed.
Yeah, if the package is installed, we can use it. Now, the tricky thing here is if we do it this way, you still have to have the model package around, and maybe you don't want to. Like maybe you can move everything to schema record, but just be in legacy mode. But we'll have to figure that out if we want that. Like right now, the migration support obviously lives in the model package, so like it's not like you could use the fields, those legacy support fields, without using the model package anyway. So probably we should just keep it this way, but maybe at some point in the future we split that part out so that you could get rid of the rest of the model if you wanted to. Probably though, it's best if we leave it with model just from a convincing people to migrate perspective, because like it really kind of, oh, I'm still importing from model, I'm not using model. Okay, maybe I should stop using these things.
Yes.
Maybe this is what I should be working to delete. What we can do here is we can just do this has model package, and we come down to our switch statement, and we say if has model package, and maybe if we just assert here, so if not has model package, we will say assert cannot use belongs to fields in the schema unless at Ember data model is installed to provide legacy model support. And we don't need to provide a Boolean here, because like we just always going to throw this. And then assert gets stripped in production, and so in production we're just going to return null. So you don't have a relationship anymore. Congrats. So we'll do the same thing with has many, and if we don't have the model package, not use has many fields, and we probably should make this error nicer. Maybe like field name on field.name should likely be migrated to resource. A resource. It's probably more that we can do than that, but we'll start there. To be a collection field. And then in this case, we'll just like return an empty array. So yeah, you're just, well, no, because it has many's.
Yeah, just to not break the app.
Yeah. Well, we should probably do if we say like if field dot options dot async, or return. If you're async, let's return a promise, just so it's like a little bit less likely to fully blow up. Return.
What about below?
Yeah, something like that. I think it's easier with belongs to just always return null. Yeah, I'm gonna ignore the async case for now, because the problem is the promise many array will sometimes have a for each on it.
Right.
So we would want to do a promise that has a for each that just does nothing. I think. We'll just leave it in an empty array for now.
Okay, it's good enough.
Yeah, it's good enough for now. All right, so then we need to gain access now to the legacy compact. So what we're gonna do is I'm gonna come back up here, and I'm gonna say const get legacy compat or get legacy support equals has model package import sync at Ember data model, and then something from there. I'm not sure what yet. Else, we're gonna do null, and let's go see what this import needs to be. So in model, currently we export just public things, but in private we have lookup legacy support. So we need to import this from private. So Ember data model dash private and dot legacy port. And then for TypeScript, which I think I need to fix my extension here real quick. There we go. All right. Let's grab that. Now it's going to say it's unknown. Why is it unknown? Shouldn't be unknown.
Did the import come proper place?
Yeah, that's the right place. I mean, it's finding a type definition. I know what it is. I think, does it take a generic? We should change import syncs type to take a generic. Yeah, we should PR a fix to this, but it just means we have to cast. So we do like that, and it's like as type of import. We'll just do the dynamic import here. And then I can't find that, but that's because we need to do two things. The first is that we need to put a peer dependency on Ember data model. And then we need to do Ember data model will be injected, just like everything else. That's a PNPM thing. And then we will need to do Ember data model will need to be a peer dependency here. And then what we want to do is do a peer dependencies meta. I don't think we have one of those yet. No. So those do peer dependencies meta and at Ember data model. And sign is true. So it doesn't.
What it does?
So what this does is this means that like someone doesn't have to have this peer dependency. It's not required.
Okay.
So we should be able to run install now, and it's probably going to yell at us because I think model has its own dependencies that we don't have. So it's probably going to be like, hey, you also need legacy compact. We'll find out. I forgot to run this the way that doesn't like hide the output. So like we might not see the issue. After this finishes, I'm going to rerun it. It won't blow up. It'll just be like it's like a quiet hint almost. Okay. So here's what I thought. Okay, hi, schema record has dependency and model. That's expecting legacy, compat, and inflector. So we're just going to put those in dev dependencies for now. But the thing is that because nothing in the ecosystem anywhere handles handles is that actually the latest? Yeah, okay. Because nothing in the ecosystem actually correctly handles peers, I think that we might have to redeclare the peers here as well, but we'll get back to that. Run that again. All right, and so while we're waiting on that, in our TS config, we just want to make sure that we've grabbed the types. So we'll just do like this, and do the same thing for our model. Model. So paths, our TypeScript setup relies on two things. Paths says this for these types for this is exactly where to find them, which avoids duplicating the types, because if instead it tries to find them from node modules, then each package will see it as being distinct, and it will
Yeah, that would be a
a lot of duplicate work. The second thing that we do is we use references to say, hey, types, you might find pre-compiled types here, so that you don't have to do any extra work when you're doing the type checking. And so between these two things, we do a lot less TS work it makes our types work a lot nicer. So now,
Are we doing PNP
I think it's done. I'm gonna reload this window.
next?
Yeah. And so now we should be getting this as a function or null, and it is. So that's great. So now what we need to do is come back down here. And in these cases, because I've basically done a check here, I just use a non-null assert, but like you can also just for safety, like expected to have a get legacy support function and legacy support. All right, so now it's going to make sure that's non-null for us. We should never hit that assert, but just it makes TypeScript happy, so we do it. And so like we're just doing the get, so we just need to do return of get legacy support for probably this. We might need to pass something else in here, but it's probably this.
Okay.
It might be. It might be receiver. Maybe we'll do this. And now it's going to be like, yo, dude, you can't do this, right? And the reason it's going to say, yo, dude, you can't do this is it doesn't know that you've added the minimal legacy support into your schema.
Okay. How
Right?
do we fix that?
So what we're just going to cast this. But what we can, I think it needs to be receiver. Yeah. Because we want it to run, if it accesses anything, we want it to run through the proxy. So we need to, the receiver is the proxy. So we want it to run through that. So we give it the receiver as the instance.
But why double cast?
Because the receiver knows that it's not that. So you have to go to unknown first to go to that. Now, the thing is we want to make sure that we were actually allowed to do this as well. So I'm going to say assert can only use belongs to fields when the resource is in legacy mode. And I think I have a Boolean for that up above. Yeah, so this legacy mode legacy. Yeah, I can probably just do mode legacy. Just gonna do that for now, right?
Mm-hmm.
So that's just like an extra check on this. This is, just remember, we're doing this cast because we don't know that those other fields are present. Like if you're in legacy mode, those other fields should be present. So that's just kind of like the small bit of enforcement there to make sure that we're lying on this type, but we're kind of lying honestly
Okay.
in this weird way. So it can only use has many fields. All right. Now, yes, we wanted to then call get belongs to, and it was so field dot and that is going to go ahead and handle all of the is this a proxy versus is this just a record, all that kind of stuff. Yeah, so that should, we might have to do a little bit, we might have to do something about the identifier, but I think overall, like, this should just kind of work. And then, and I think this should just be get has many. So then let's try to write a test first.
Exactly.
Right? But let's see here. Tests. So we have WarpDrive schema record tests. Let's just open up something here, go into the legacy, go into reads, just copy a file over, and let's rename this as a starting place to, I'll call this relationships. So in this test, we register our derivations. We have our defaults that we can bring in. We created a little user type. We probably want ours to, let's start with a belongs to. So let's say, we'll leave name and we'll say belongs to, or we'll say best friend is a user or null. And we'll say friends is a user, right? So we're gonna start with synchronous relationships.
Okay.
So we want to register a resource that we can then use with these tests. So I'm gonna we can use we can use sync belongs to. Right?
Let's rename the module as well.
Yeah. So legacy reads, this was relationships. There we go. All right. So we can use sync belongs to. So now what we want to do with this is we want to register a schema. So we're going to do it with the legacy fields,
Okay.
which means we also needed to register that legacy derivation. And we are going to add in this name one as well, but then just so that we have something that's not a relationship to work with. And then we're going to say name best friend. Type is also user. Kind is belongs to. Options is going to be async false, inverse best friend. Okay, so you'll notice that we got nice TypeScript.
CS support.
Yeah. All right. Cool. So
Do we want to
this
do users as well?
um,
Friends?
we'll do that in the next pass.
Okay.
Because this test we're just going to focus on the belongs to. So here I've created a user, and let's do let's actually do a push instead of a create here. So let's do push, and then we're going to say data type user ID 1 attributes the name Ray Skybarker and relationships best friends data type user ID 2, and we'll go ahead and include that user here. So included type user ID 2 attribute. My dog loves my buddy Matt more than me. This is my dog. Yes. I need type. And yes. And then sys.
Is it single if it has included?
Yeah. Hold on. I'm trying to figure out this push. I'm pretty sure push can return date. Go to the type definition. I need to remember. Maybe we don't. Okay, so we take push t. Oh, okay. I need to do single resource docking. It's the wrong type. And this is. Yeah, that doesn't quite seem right. Am I importing this in the wrong place? I might just have to improve this type still. So I take in a generic. Okay. Duh. It's simpler than I was doing it. It's just use it.
Nice.
Yeah. All right. And then basically it infers from the structure of the data that it's the single data document. Yeah. And if I did like that, it should yell at me because it knows that the type is user. All right. So, cool. We have our array. Now our array is a user. You'll We'll say down here, array.id, it should be ones. And you should say array.name is Ray Skybarker. And then our final test should be assert T-full. Ray.bestFriend. We're going to do Matt. And to get Matt, because Matt wasn't included, we're just going to do a peek. And we can pass in user, and we'll say user and 2. And Matt should be there, but I know I just pushed it in, so I'm just going to cheat. So I'm Matt. So now
What do
So what I did here,
Yeah, with the exclamation mark.
this is a non-null assertion.
So TypeScript.
Yeah. And we want to go both ways with this. So equal Nat.best friend, Ray. Ray. All right. Matt has Ray as best. All right, let's go see if this test passes. So we want to go into tests, square record. We probably can just do. Let's take a look at the package.json for that real quick. Each test app in here is a little bit different right now. I think this one is an Ember one. Yeah, this is an Ember one still. So we're gonna do start. Yeah, we'll just do start. All right. I probably need to be test port, but should be okay. Yeah, it needs to be test port. Let's fix that so that the next person has a better time.
I never use test or what I.
It's a way to make it use a specific port or a random port instead of the hardwired port. Because we have so many different test apps, we can't use the hardwired port because it might conflict. So if you set it to 0, it picks a random booking port. So I'm gonna open link. Let's use Chrome for this one. Safari is my default browser, but I prefer Chrome for debugging. All right, so we can use sync belongs to. So we didn't quite get there. So has the unknown kind belongs to. All right. So something doesn't support it yet. No try catch. Inspect. Console. And let's figure out that. All right. So we fell through to here. Yeah. Why? Well, I think we misspelled it, which is surprising that we didn't get yelled at. No? There's belongs to. Okay, so that's not misspelled. Oh, I bet, you know what it is? I bet you we haven't rebuilt. It's rebuilt.
Okay.
We don't we can't currently automatically rebuild library code in a way that the test apps pick up very easily. There's a lot of challenges with hard links and turbo and all that. So it's annoyingly manual right now.
Do you know how to fix that?
Well,
What would be a good?
I had come up with a way to fix it when I was working on the V2 add-on work, but it was dependent on rolling up the types working a specific way, and that didn't pan out. And so once that didn't pan out, went back to square one of it doesn't work,
Okay.
unfortunately.
We restart this.
So in theory, we should be able to just trigger a build here. So I think I can just hit save here, which will trigger a build. It's saying I got a build error though, so let's see what that was. A lot of times I don't run the test and build command together. I prefer to keep them separate, but what happened here? That's interesting. Let's go look at how that compiled. I think what's happened here is our use of import sync tripped it up somehow, is what that's suggesting to me. So if we go back into record, remember at the top here, we did, dependency satisfies and import sync. So in our dist, we should have in record, we have dependency satisfies and import sync. So that's still there. I bet you our test app doesn't have it though. So what's in our test app? Our test app. Our test app does actually inject these things, so they should be there. All right. So let's see if we can get any more info from here. So can't resolve, Ember data, model, private, model methods. Oh, that's interesting. Oh, well, let's go look at this some more. I shouldn't have to specify Ember data things as externals. That's supposed to happen automatically. But I wonder. It's saying model private model methods. And it's trying to get that from schema record. That's not quite right though. Schema record never directly imports that. So it's saying in record, we are somehow trying to resolve model methods. Let's take a look at record one more time here. What did we maybe let's hit the refresh button just in case something's stale in the build. I'm not seeing oh, there it is. Why are you here? You're a side effecty import. Why are you here at all?
The departments.
Ah, such a troll.
Do you think TypeScript is necessary?
I mean, I think it's definitely helped. It's like such a such a I don't want to say complex, but it's like definitely not a trivial project.
Yeah, absolutely. I don't know, like something that's well decided to teach, better on board of that. I don't know. It's because I am not really good at it. That's for sure. Like what else?
I definitely think it took me a couple years to get good enough at it that I felt there was more value than pain. But once I got to that level, it's significantly more value than not having it.
Okay. So just in
Yeah, I think what it is just like it's a little bit like learning any new language. I think a lot of people maybe approach it as just an extension of JavaScript, and it really is more than that. And you got to learn to like with any new language, you got to learn to think in that language. And once I learned to think in that language, it's super useful. But until you learn to think in that language, if you're trying to think in JavaScript land still, like it's more painful. Uh, I do think I embraced usage of it easier, even if I wasn't seeing value, than a lot of people do. Simply because the way that I write and structure code has always lent itself well to being typed because I prefer const. Like I like things to, I like to, I like things to like be asserted that they're present when they should be. Like I use assert a lot even without TypeScript. I try to shape my data so that I'm not changing function signatures or don't have polymorphic function signatures, don't have uh, polymorphic types. I like to use interfaces and like conceptual interfaces, not TypeScript interfaces. I like to design with interfaces in mind instead of classes in mind. So like, there's a lot of things that TypeScript kind of like encourages you to do that I already just did as a style. So it kind of really fits me well. But even with that, it was like probably 2 years where I was like, why doesn't this work? And it's like, well, I just don't know TypeScript well enough.
all right.
Yeah.
Let's speak about build.
Yeah, it's trigger a build. Save this. And waiting for runners.
It's a different sport time.
Yeah.
Yeah. There is a rate. The other puts will pick the browser.
Check this out.
Yeah, it would be.
Yeah. So
I was super worried when I see that. Because
legacy mode. We're looking for legacy reach. It is there.
that's awesome.
Yep. And so that was easy to do entirely because of the factoring that we had done around encapsulating the craziness of legacy relationships in the past.
Yeah.
right? Like if that was still on the record class or still like in something like internal model, we would not have been able to do that. But because we already had conceptually said, okay, this is just a state container specific to relationships that we need to be able to, you know, use to isolate that craziness. Like, hey, turns out we can reuse it. So
Can we write async example?
let's do that. But like let's do a test for sync has many first.
Okay.
So it was friends, right, and has many, and we'll go ahead and do an inverse friends. So this is what we call a self-reflexive or self-referential. Not no no. It's a reflexive relationship. Reflexive meaning it points back at it itself. There's like a whole terminology guide to this. That terms are weird. But I wrote the terminology guide because I was like, I'm tired of explaining this to people.
That's a way.
Yeah. So yeah, if you go into the guides and you go into terminology, we go to relationships, you notice that, hey, what the hell are these? So self-referential, you point back at the same resource type. So that's when a user points back at, it has a relationship to other users. Self-referential. Reflexive
What we have is the best friend.
is, yes, right? Reflexive is, well, best friend is also reflexive. So reflexive is not only do I point back at a user, but I point at exactly the same property as myself. So best friend to best friend,
Okay.
right? Circular is not only do I point at another user and the same property, but I actually point at my same instance, which is possible. Like we allow this.
Okay.
So you can have
Cheap.
right. Like so, I can have let's say that
Yeah, kind of like a useful example.
a useful example like is actually it's been a while since I've had one of these. I don't know if I have like a canonical one, but like you can imagine like
Yeah, we have here heck of best friend.
yeah,
It's like, I am my only friend.
yes. But like you might imagine like who's the legal guardian. Well, sometimes you're your own legal guardian,
Okay.
right? So that would be circular. Um, but yeah, so we actually support all of these scenarios. They're all crazy. All that.
It doesn't blow up.
Yeah,
Because circular usually means that something will
yeah.
go into the endless recursion and blow up.
And this is actually one of the differentiating features between us and something like Apollo. Like you really can't have GraphQL doesn't have a way to describe circular relationships. In fact, it doesn't even have a way to describe relationships. It really only has a way to describe pointers, meaning that you can go from like A to B, but you can't go backwards from B back to A.
Yeah.
Uh,
I think they say it's a feature on the Reback. Oh, yeah.
yeah, and I would say it's it's a bug. So all right, so we wanna write a has-many test. So we have friends. We point back at friends. So we're just literally gonna take our same example, and we're gonna change this to being an array now.
Column.
Dan, thank you. And we'll say friends here. And this will also be an array. And so now I should be able to say array that friends 0, that friends 0, and we can also just like put a length check in here. I don't know why it's decided to start auto-completing this way lately, but
Yeah, kind of weird.
yeah.
But could you tap on it?
I think it might be, I think I might have adjusted my Copilot settings recently. Like array as only one friend. All right, so let's go see if that works. Back here. All our tests are passing. Let's go find this legacy relationships. Make sure it's running. All right. So there we have it. So easy. All right. So come in here. That we got that. That's just the read case. We still have to do reactivity tests. We still have to do write tests, all that kind of stuff. But like, let's do async real quick just to make sure. Although like, I'm pretty confident in that.
Yeah,
The way
judging by your voice, it's really confident.
yeah. Just I trust the factoring that I did on this all those years ago.
Yeah.
Uh, we'll just literally copy both of these tests. And we are going to change them to being async. Async, and I'm going to make this async here so that we can do some awaiting in these tests. And then we'll start with the belongs to. So we want to say this is async true. And then we will come down here and we will say const Ray best friend equals wait. And I'm going to say const Matt best friend equals wait.
But it's really a wait if you push the go right in the store.
It is. And we're going to do assert strict equal. Or Alice. It's going to be a promise belongs to. Should be able to do this, I think.
I think you need to put OK. Assert OK.
All right, so we're gonna start there async.
Should you move it down?
So remember how like registries suck?
Yeah.
Well, let's make this type not suck. So I can just come in here and I say, actually in this test I needed a different user type because that's why it's telling me. It's saying, hey, this isn't actually async. So I'm just gonna say, all right, well, my type user equals, and I'm gonna say, I don't need best friend. Well, I guess I do need best friend. I don't need the friends one here. So best friend, and I can just do the really basic one and say it's a promise. But it's probably easier to say I'm promise belongs to. Not those things. And since I know I'm just doing read cases, so boom. Hey, wait, that works now. So like it's one of the reasons that registries weren't going to work for us was actually just our own test suite, because we are dynamically defining models all the time in our tests. Well, I can't. If you use registries, once you've registered the type once, you can only ever use that type for that thing.
Yeah, that's hard.
It's hard. So what that led to was, well, if we're going to do registries, we have to have a registry of registries, so you can override the registry in every single test. If you thought the type is infinitely recursive problem was bad before, the type is infinitely recursive problem becomes massive after that. So it just like the branches in which I tried registry kept getting to like 30 to 50,000 lines changed and like being nowhere close to being usable. And it was just like, okay, like this is too bug of an effort. And that was actually why I got to the point where I said, I don't think we can ship TypeScript this year. So a year ago at the Ember face-to-face, when we were discussing, what is Polaris, the definition of Polaris, in terms of Ember data or WarpDrive, my answer was, schema record, request manager, probably universal if we can get there, but it's not TypeScript. We cannot ship TypeScript unless other people want to step up because I've tried, it's too much work. I'm never going to get over the line myself. It's just going to take a massive Herculean effort. But that was because of the amount of hours I had sunk into attempting to type it with registries. Like, I had 3 separate PRs I had tried it in. Each one of those PRs was well over 100 hours of work, and none of them had landed because it just kept stalling out because it was so hard to do. Once I kind of arrived at, you know what, honestly, registries have so many actual problems in practice, not just for ours, but in actual apps as well. Is there a better way? You know what? I bet you the flexibility of brands is going to be better, and it's going to solve all these other cases that we have too. And once I arrived at that, it was like less than a day, and I had shipped a canary at TypeScript. It's like, okay, this is better.
But my question is,
Yeah, we're gonna.
do you need to bring this
Yeah, we're gonna.
down because they already awaited?
Well, I'm gonna assert them now.
Okay, but like,
So that Ray best friend is Matt. Actually, let me just grab the old ones here. It's the same assertion. I just changed it. So like that. So let's see. Like this might fail. Because I don't remember if I think I'm just exporting a type. This is probably gonna get mad at me. But the rest of this is probably gonna work. So let's go see over here. So it's saying it's passing, right? No, it's. Well, I guess I'm actually exporting it. Cool. Didn't realize I was, but cool. Where does it import from? Huh. Oh, okay, I see. I grabbed it from the private one. The public type one is only a type. So if you import from data model, you would get just a type. It probably, because I did instance of it, probably knew I needed the actual thing. So I don't know. TypeScript is cool sometimes. All right. Yeah. So we can use sync belongs to. We can use sync has name because async belongs to. All right. Let's do the next one.
yeah, I think we need to change the type here as well.
Yeah. So we say your async true. I'm gonna go grab our nice new type. And again, I'm just gonna kind of do promise array of user. And this is gonna be friends. And that's the same. That's the same. And then up here, we're gonna want to do kind of this kind of deal. And we're gonna want to do kind of this deal. So I'm going to say that, and we'll do plural and plural. And this is just gonna be rounds.
It's a common T there.
All right, and so this is now just made up friends, and this is gonna be map.friends. This is gonna be a friends, met friends, and then this should be a this many array. And let's see how that one's doing. All right, so this one is getting a little mad at us. All right, same. Oh yeah. No, no. Friends data.
Pushes spine, as many friends. Hive is okay.
Right.
So what's happened again? Why does it yell at us?
It's trying to hit network, and we haven't set up the store in this test suite to have an adapter. And the relationship fetch in the legacy world always has to use adapter.
Yeah, please.
Uh,
But why belongs to work?
That's a good question. So we got to figure that out, right? Like I mentioned before, though, that these legacy relationships just have a crazy amount of complexity about when they decide to fetch and what the semantics of that are.
So like in the case where it's stuff like, okay, I have it.
Yeah. Uh,
Probably because we included full data there.
yeah. So I'm gonna do this as well, just to make sure on that. But both of these should work. Uh, let's go through here. So let's go. This is giving us a good error, and so all we really want to do is do no try catch, and then go see why we're calling this. So um, we got here because all right, so in get has many, we said are we async, and we are.
Yeah.
So it says, all right, make sure that we've fetched this async has many before, which has a crazy amount of logic. So we can go into fetch async has many, and we say, do we have a loading promise? If so, we use the existing one we have. Otherwise, go get the data from the cache for this relationship, and go find the data for that using that data. All right, so then that method is going to go through and do the, should I find via link? Should I find via data? And it's only going to make a request here. Exit if it has to. So like,
You think we can move the adapter check lower or what?
possibly.
Here is that.
Yeah. Um, so all inverse records are loaded. Oh, no, that's not what I wanted to do. There. Long. We're going to say. I think what's going to happen here is we are just returning. It's going to be easier to go read this code in the original source.
Yeah.
But I think what it's going to happen is we're just going to return. But we've already looked up the adapter, and Aaron, which we don't have an adapter. We probably just need to get an adapter in here somehow. let's go look at the source code for this. So this is going to be in model, and this is the legacy relationship support. And we're looking for fetch async has many.
Yeah.
Here. And what we said is go fetch this guy, right? So go to this guy, and we say, here's the adapter. We're using that to check if
we should fetch value.
yeah, right. So we might need to like add a conditional check here. Maybe if there's no adapter, then we're not gonna do that. That might be a potential thing to do here as just a nice support thing. Um,
What should we do? Like to do it and keep the ball on the relationships?
well, I want to see what would happen here. So we have all inverse records are loaded, right? So should find via link says it has to be this, and it has to be this, and one of these two things has to be true, and one of these things has to be true. So we shouldn't force reload here. That's going to be false. That's going to be false. That's going to be false. That's going to be false, which means that's going to be true. And that's going to be true, which means that's going to be false. So this is false. So we're not going to do this. So we can close that branch.
Can we go back to test?
Well,
Are we sure we loaded everything?
yeah. So here, we're going to say, as we see data, that will be true. So this, we should prefer local cache. So we shouldn't just end up returning. So find, yeah, so we're just gonna end up returning. So that method, async, fetch async has any, we're just gonna end up returning. And so we're gonna get not promise. And so we're just going to automatically resolve the many array. So this is what we're gonna do. However, we're erring because of the lack of an adapter. So I think just to keep things moving, what we'll do is we'll just do the optional thing for now. So you need that. And it says the adapter here. And do you use adapter at all in here other than that? I don't think we do.
We need to check how it fetch value.
Well, that's later. I don't think anywhere else in this code we're gonna actually make use of the adapter. I think it was just literally to say, do we have this method? Yeah. So we're gonna do that.
And now we need to rebuild.
So we need to rebuild stuff. All right, so we did that. So let's go. Yeah, so let's go back to our tests. And just make sure that that's rebuilt. And I'll go in here and refresh. And we pass now.
Whoa. Big stuff. Wow.
Yeah.
Ship it.
Ship it.
Crazy how easy it is.
Schema record is a very well thought design. and is building on a history of specific design principles that like
Yeah, just like Ted said,
yeah
when you have it this design, it's easy.
yeah
Yeah, we still don't have rights.
but yeah we still don't have rights, and we haven't written a test to confirm that it's reacted yet, but we got the main thing, the read case here. So and we'll come back to that, but like remember the polls. Let's open some pull requests here. So that'll run. Probably going to fill some lint jobs because we spent no time running lint. Um, why did this guy fail a lot? That this fails a lot for just random ass reasons. It's not a required check. Canceled because it ran out of time. The special builds often like have that problem because like lots of weird things can go wrong in terms of a caching perspective, and so sometimes time just blows up. It also like tries to do a build where it will install the absolute latest possible copy of everything to see if we drift if there's an error. Sometimes there is. So it's like like it's more of like a canary in the coal mine kind of check. So like
Can we, for now, like stop this,
yeah,
like wrap it up, then we start the recording?
I'm gonna actually just merge this and be done. And then we'll see what happens here. And yeah, let's actually just wrap this up.